Hello everyone, welcome to All Chemistry. So, as requested by all of you, alcohol-phenol-ether, another question and answer discussion. And this video will be a little different. Not only question and answer discussion, I will go for topic wise. First, I will tell you the topic and what kind of questions may come. That I will tell you, and that will be definitely helpful for your exam, for your first semester examination. And for organic chemistry, everyone have a doubt, confusion that how to study, and that video I have already covered, that how to study, what should be our strategy, what type of questions may come. Few questions I have discussed already. If you have not seen that videos, you see the videos are given in the description box. In the iCard also you can get the video link. So let's start. What we will go for alcohol phenol ether in a different manner, the topic first, and then what kind of questions may come. Not directly the question, few questions I will discuss, and the full question answer PDF as usual you will get in the description box. Download it from there. Few unsolved and solved question will be there. So without wasting any time, let's get started. The very first thing is physical property. Now in case of physical property, what we will go for first? The first thing is what kind of boiling point, how the boiling point will change, how the melting point will change, how hydrogen bonding affects the boiling point, melting point, and of course don't miss the IUPAC nomenclature. So regarding this concept, let's see one question. Okay, our very first question, as you can see here, which of the following has highest boiling point? If we go for the boiling point thing, in between OH, alcohol, and in hydrocarbon, alcohol will have the highest boiling point, higher boiling point because of hydrogen bonding, as because all the four options are alcohol. So more the branching, less will be the surface area, less will be the van der Waals force of attraction. So lesser the branching, more the long chain, van der Waals force of attraction will be high, and the boiling point will be highest in case of butanol here. Okay, and in this chapter we have many type of reactions. First, the preparation of alcohol, we have preparation of alcohol, then preparation of aryl alcohol, aliphatic alcohol, aromatic alcohol both, and then ether, preparation of ether. So in that reaction preparation, reactions of alcohol, reaction of aromatic alcohol, aliphatic alcohol, and ether, I have just chosen few important reaction what I think that they are very important. First, whenever we are going for the method of preparation, hydration of alkene. So suppose one alkene you have and we are adding hydrogen, how in asymmetrical alkene how the hydrogen will be added, or if we are adding HBr how it will get added, or if we want to make alcohol, then where OH will be added at the corner position or at the middle position. This selection rule is very important. And then Grignard reagent. Grignard reagent is CH3MgBr. We can take, or in place of CH3 we can take ethyl, methyl, propyl, anything. And the beauty of the Grignard reagent is if we have ketone, from ketone we can get alcohol, from acid we can get ketone, and from ketone if we got alcohol. So like this way the reduction can happen by using Grignard reagent. Then we have hydrolysis of alkyl halide and reduction of carbonyl compound by various reducing agent like lithium aluminum hydride, lithium borohydride, etc., and from primary amine also. So let's go for one of the example from reaction side. Okay, which of the following reaction will yield phenol here? So which of the following reaction will yield phenol here? If we go for chlorobenzene fusion with sodium hydroxide, it will give you sodium phenoxide O minus Na plus, and after hydrolysis of that we can get phenol here. Then we have amine. By adding sodium nitrate and HCl, sodiam nitrate and HCl, we will get benzene diazonium salt, that N2 positive, and by hydrolysis we will get phenol. And by adding oleum to that, oleum means H2SO4, that one is source of SO3H, and by hydrolysis of that in presence of sodium hydroxide base we will get phenol also. But if we add only sodium hydroxide HCl, it will not give you phenol. So here option will be option A, B, C. All the three options are correct, and from all the three options we can generate phenol. Next, go for our next concept. From our next concept, that preparation of ether preparation of ether from alcohol. So that preparation of ether from alcohol is Williamson synthesis, and ether preparation Williamson synthesis is very important. What will be the reagent, what type of reactions, and what is the name? Williamson synthesis. The reaction is given sodium alkoxide and alkyl halide giving ether and sodium halide. So this reaction having sodium alkoxide, alkyl halide, ether, we are getting ether and sodium chloride, sodium halide. So this reaction is called Williamson synthesis. So this one is another question. Next concept we have two important reaction I have selected: coal-based reaction, Reimer-Tiemann reaction. Instead of that, other reactions are also important, but they are more important than other reaction. So these are the most important reaction. You can go through it. And the other thing, the Lucas reagent test, the FeCl3 test, azodite test, as well as the iodoform, these three are also important. So let's discuss two, three questions from this concept. See, our question here, one of the reaction is given, OH CH3, that one is we have in the para position CH3 and OH group. Intermediate we got, and then one O minus Na plus salt and aqueous HCl is giving us the alcohol with a substitution. So here a substitution is added at the ortho position with respect to the hydroxy group. Which of the following reagent is used for this conversion? Aqueous sodium hydroxide CH2Cl, aqueous sodium hydroxide CH2Cl2, aqueous sodium hydroxide CHCl3, aqueous sodium hydroxide CaCl4. So here answer will be aqueous sodium hydroxide and CHCl3. And the corresponding reaction, what is the name of the reaction? Here the name of the reaction is Reimer-Tiemann reaction. Another reaction, Kolbe reaction, is also important. For Kolbe reaction, what we can get, suppose we have phenol here, and if we have added sodium hydroxide in presence of carbon dioxide, then we can get the para hydroxybenzoic acid. So CO2H group will be added in case of Kolbe reaction. Okay, our next question is very basic question from IUPAC. Name of ether. We have that one ether is given, and IUPAC name is required here. As an answer, we need to know the IUPAC name. So in between IUPAC name and common name, we may have any confusion, because methyl phenyl ether is its common name and its IUPAC name will be methoxybenzene. So if it is wanted that IUPAC name, then go for the IUPAC name methoxybenzene. Okay, then identification type question. Acetone and formaldehyde can be distinguished by which of the following tests? If we have acetone, that means CH3COCH3, and formaldehyde H3 double bond OH. So in between these two, which kind of reagent we can use to distinguish in between that? We can Lucas reagent is used in case of alcohols. Azodite test can be used in case of alcohol. None of the above will not be the option. Here iodoform test can be the option, because acetone contains CH3CO, that group with alpha hydrogen, whether formaldehyde does not. So by using iodoform test, if iodoform CHI3 will form in case of acetone, then we can identify that one will be the acetone. And here what reagent we will use? We will use sodium hydroxide and iodine as reagent in case of iodoform test. So I hope this video is little helpful, and the whole PDF with more questions solved and unsolved we will get in the description box. Download from description box. And if this video is little helpful, please give a like, and please do share with your friends who is going to appear in semester 1. And if you have not subscribed to my channel yet, subscribe it, and your one like giving motivation to make more videos. And for this video, that's it, and thank you very much for watching.